Developed by Cotton Incorporated and financed by the Importer Support Program of the Cotton Board, this CD-ROM on knit product manufacturing introduces you to how knit fabric is constructed and designed, so you may better understand the production of quality cotton products. Building cotton demand and profitability, Cotton Incorporated is the fiber company of the U.S. upland cotton grower and importer who provide the funding for our efforts. Through research and promotion, our programs enhance the cotton business from field to fabric, from retail to customer. The Importer Support Program manages a special fund designed to focus on projects that are targeted to importer needs. This education effort was identified in 1998 as a key initiative and has been one of our most successful programs. Now, we present you with selections for The Art of Knitting.
Knitting. What makes it unique? Unlike woven constructions, which are rigid and stable, knits more easily form to a change in shape. The intermeshed loops of knits allow for flexibility as they stretch to fit the form. Although there is evidence of techniques traced back to 1000 BC, knitting did not become common until the 15th century. Worn for comfort and style, hand-knitted fabrics became so popular that by 1488 the British Parliament controlled the price of knitted caps. Henry VIII was the first monarch to wear fitted knit stockings instead of loose trousers. Elizabeth I preferred stockings knit of silk. To increase production, in 1589 a British gentleman named William Lee invented the first mechanical knitting frame. Its use transformed the art of knitting. Knitting technology has evolved from the first knitting frame to the high-tech machines currently used. One of the most significant developments was an ingenious but simple addition to the knitting needle itself, a latch, which enabled higher production and versatility that carries through to the textile manufacturing of today. Ever growing in popularity, knits are a key entity in the fashion industry. Constructed to appear natural and uncomplicated, but imparting a confident look, knits are used for all types of clothing. Sportswear calls for form-fitting garments that stretch as the body bends or runs. Casual wear calls for products that are comfortable, retain their shape, and require little effort to maintain. Dress wear demands elegance and simplicity of style. When it comes to apparel, knits are unsurpassed in their broad range of applications. Knitting is defined as the intermeshing of yarn into loops to form fabric. There are different ways that yarn can be subjected to the needles for fabric formation. In knitting, there are basically two systems. These are weft and warp. What makes them different? Let's take a close look at each one. Weft knitting is accomplished by loops formed in a horizontal manner by adjacent needles. The most common machine used for weft knitting is the circular knitting machine. This machine creates a tube of fabric in a spiral configuration, around a cylinder. The width of the fabric is determined by the number of needles on the machine. One revolution of the machine completes one course for each yarn fed. A second type of machine can be used to produce weft knit. This machine produces fabric on needle beds that are flat, so it's called a flatbed machine. Regardless of the type of machine used, in weft knitting, needles placed next to each other knit one after another in sequence to produce one row of loops from the same yarn. Here is an illustration of how loops of yarn are created by a weft knitting machine that knits yarn in a horizontal manner, so that the loops are formed from right to left. If you analyze the structure, you see a pattern of loops arranged in rows and columns. The horizontal row of loops, produced by adjacent needles during the same knitting cycle, is known as a course. The course count is measured by the number of courses per linear unit, expressed as inches or centimeters. If this drawing represents a 1 inch by 1 inch area, you identify this as 5 courses per inch. The vertical column of loops produced by the same needle knitting at successive knitting cycles is referred to as a wale. The wale count is measured by the number of wales per linear length. In this same drawing, there are 5 wales per inch. The second system used for knitting is produced by machines that are designed differently, to vertically knit. This illustration shows you how warp knitting, in contrast to weft knitting, is accomplished by forming loops in a vertical direction. If you look closely at an illustration of warp knit, you see that the yarn is intermeshed vertically with 2 wales. With warp knitting machines, each individual loop is created from separate lengthwise yarns. Wound onto a beam from yarn packages in a creel, the yarns arranged as a warp must be placed parallel to each other. Normally, for the most basic of fabrics, each yarn needs its own needle. If 1,000 needles are used on this machine, there needs to be a minimum of 1,000 warp yarns. If there is more than one yarn provided for each needle, more elaborate fabrics can be produced. With warp knitting, individual needles knit simultaneously across the width of the machine. Loops are formed by needles knitting a series of warp yarns fed vertically and parallel to the direction of the fabric formation. Warp knitting machines are typically used to produce tricot, rochelle, and crochet. Knit fabrics can be made on more than one set of needles. Unlike single knit fabrics, double knit fabrics are produced from 2 sets of needles. You've seen how circular machines can be used to produce single knits, but they can also be set up to create double knits. To accomplish this, a second set of needles is arranged in a dial above the cylinder. This dial has slots that hold the needles at a right angle to the vertical cylinder needles. This illustration shows you how a circular knit machine has tricks in 2 places: in the cylinder below and the circular dial just above. The dial has grooves cut in the outer perimeter in the same cut or gauge as the cylinder. Another view shows that the needles in the dial rest horizontally in their grooves. Also, there is a precise gap between the cylinder and dial. This distance is referred to as dial height. The dial height is important because it directly affects the stitch length, which controls physical parameters such as weight, width, thickness, strength, and hand. When double knit fabrics are produced, the knitting cycles of knit, tuck, and float are the same for the dial as they are for the cylinder. The needles in both the dial and cylinder have butts and are cam activated. 2 sets of needles are used, some are not needed. As yarns are in the fabric form, the goods are moved inside the cylinder as weft knits. Another type of weft knitting machine, designed to make single and double knit fabrics, is a flatbed machine. These machines may have the 2 needle beds in the same plane, but usually they are set up in a V configuration and then referred to as V-bed machines. These knitting machines are used to produce tubular fabrics or flat panels that can be put together to form a garment. Because the width within a panel can be made to vary, this system minimizes waste and sewing. Also, the technology has matured so that a complete garment can be made on this machine. Here's how V-bed machines create the loops required to produce a double knit fabric. First, loops are at rest. Then both loops clear the latch. New yarn is received, and both loops are cast off as new stitches form. You may notice that these actions result in a fabric that is structured differently than a single knit. You've seen how weft knit fabrics can be made on either circular or V-bed machines with 1 or 2 sets of needles. Remember, when it's 2 sets of needles, we define it as double knit. Let's start by taking a look at the big picture, the basic configuration of most knitting machines. Commonly used for single knits are circular knitting machines, which pull their yarn supply from creels located either above the machine or next to the machine. To make it easier for technicians to service the creels, It is more usual to find creels located at the side. In this position, less lint falls into knitting elements. Larger packages can be used, and more feeds can be placed on the machine. Whether the creel is at the side or top, the principles for circular knitting are the same. Fed from above the knitting elements, yarns move from the yarn supply, or creel, through guides to stop-motion controls above the machine, then back down through tension controls and yarn feeding devices to the knitting elements. Quality products can be produced only when stop-motion and yarn feeding functions are properly set. The intricate action of knitting, where needles form loops, occurs at the middle of the machine, between the take-up and the yarn feeding mechanism. A close-up shows you how, with circular weft knitting, needles knit one after the other in a sequence for each yarn. Notice how loops are formed horizontally by needles knitting around the cylinder, forming a tube. After yarn is knit on the knitting elements, the knitted fabric is passed over a spreader mechanism through take-up rolls and is wound into a roll. This elliptical spreader distributes the take-up tension uniformly and enables the fabric to conform to a flat tube. In this segment, we describe how needles actually do their work. How are the needles arranged, and what causes them to move? Knitting machines are designed so that each needle can be placed in a groove, cut into the outside of a metal cylinder. Before we show you how these cylinders work, let's define the parts. The cuts or grooves may also be referred to as slots or tricks. The top edge of each groove is called the verge. These cylinders are very precisely manufactured, so the diameter measured at any place is equal. Machines are classified by the number of cuts per linear inch. This is referred to as the cut or gauge of the machine. For example, an 8-gauge machine has 8 cuts per inch. The total number of cuts around the circumference of the cylinder would indicate the number of needles in the cylinder. The more needles, the wider the fabric. Now let's take a closer look at the needle itself and label its parts. At the top of each needle is a hook. Below this is a latch, attached with a rivet. Notice that the bottom edge, or cup of the latch, is curved to fit over and completely close the hook. At the bottom of the needle is a butt, which plays a part in controlling how needles activate, up or down. A needle with a latch is very efficient. When the latch needles are used to create weft knits, the knitting cycle can be completed without any auxiliary attachments. Here's how the latch needle works. At rest, or running position, a knit loop rests above or on the latch. As the needle moves up, the old loop, already formed, drops below and clears the latch. As the needle moves down, it receives the new yarn to begin forming a new stitch. The latch is knocked over by the old loop, and this old loop is cast off. The needle moves further down to fully form and complete the new stitch. The amount of yarn used to form a new stitch determines the stitch length. This is important because stitch length affects the weight, width, and aesthetics of the fabric. On modern-day knitting machines, needles make millions of loops or stitches a day. Needles may need to be replaced due to wear, but they usually last up to 6 months, depending on construction, yarn type, fiber type, and speed. Next, let's take a look at what causes the needles to move up and down. In this illustration with a side view, you see how the butt of a needle guides the needle through a path formed by cams. Each cam is designed to allow the needle to run straight or to move up and down. Here's how the needle travels through various stages. At the rest or running position, the needle runs straight over the rest cam. When it hits the clearing cam, it rides up at a steep angle, which forces the needle to rise and clear the old loop. Then the needle drops when it contacts the stitch cam. As it continues on its path, it catches the new yarn. It continues further down, pulling the new yarn far enough for a new loop or stitch to form as the old loop is cast off. The up-throw cam returns the needle to its resting position so it can begin the cycle again. Take a look at this same action while the machine works. Watch how needles run through the camways, which cause the needles to rise and fall. And remember that this machine has a cylinder that contains vertical grooves and slots to hold the needles that move. As needle activation occurs, how does the machine control the movement of fabric as it knits? There's one more part placed between each pair of needles that you need to see to better understand this. It's called a sinker, and here's what it looks like. It's a thin steel element with a distinctive shape. This illustration highlights the parts. A sinker has a butt with a place to insert a cam. It has a hold, a throat, and a nose. As the needle goes up, the sinker moves in to catch the fabric in its throat. Since the fabric can't go up with the rising needle, the old loop now clears the latch. When the hook catches a feeder yarn as the needle moves down, the sinker moves back out of the way, and knockover, cast-off, and stitch forming takes place. As the new stitch is formed, the fabric rests on the top of the nose. Here's one last view of needle activation to show you how knit fabric is formed. In this segment, we discuss the design of the fabric and the basic stitches that make up knits. There are only 3 types of loops or stitches possible in weft knitting: knit, tuck, and float. Let's take a look at the first one, the knit stitch. If every needle is fed a yarn and goes through the basic knitting cycle, the product is referred to as single jersey. All loops are knitted, and all loops look exactly alike. Look closely at this drawing of a regular knit loop. The length of yarn in that loop is called the stitch length. Notice how each loop has what can be identified as legs and a crown. The fabric at the left is technically the face side, and the stitches have an overall vertical appearance. On this side you see primarily legs rather than crown. The fabric at the right is technically the back, which takes on a horizontal appearance. In this view, you see mainly crowns. Referred to as a jersey stitch, stitches arranged in this pattern have a distinctly different look and feel from the face to the back. Another type of stitch is referred to as the tuck stitch, because one yarn is tucked behind another and hides. The pattern on the left shows the technical face for a tuck stitch. Follow the green shaded course of yarn across the pattern and it looks like a loop has been tucked behind another. The pattern on the right shows the technical back for a tuck stitch. From the back, the tuck is more visible to the eye. How is a tuck stitch made? During the tuck cycle, at feed 1, the needle moves up from its rest position and the old stitch that has been formed is held and not allowed to clear the latch. Yet the needle moves up far enough to grab a second yarn, which is put into a tuck position. Both yarns are then kept at the rest position. The knit cycle occurs with the next feed of yarn. At this time, both yarns are cleared. A new yarn is fed and pulled through both the held and tuck loops, forming a tuck stitch. The stress caused by holding one elongated stitch for an extra course causes more length shrinkage, but less in width than a regular knitted stitch. The tuck loop makes the fabric wider and thicker and slightly less extensible. What is the overall structural effect of tucks on knits? Tuck stitches can give a fabric a cellular appearance. Some people refer to this as mesh. Tucks are the basis for piqué, typically used for golf and tennis shirts, which need to breathe, retain their shape, but have some stretch. A wide range of piqué constructions can be made depending on the use and frequency of tuck stitches. The third type of stitch is the float, which is also called a misstitch. The drawing on the left is a technical face. On the face, in the middle course of yarn and middle wale, it looks like the machine has hidden the colored yarn in the back. It is not captured or knit with any other stitch. This is the float or misstitch. On the technical back, you can see how the loop floats. To produce the float stitch, on feed 1, a yarn is laid to rest behind the hook of the needle. The needle remains at the rest position. It is not activated in the float cycle. In the knit cycle, it is. When a subsequent yarn is knit at the next feed, the missed yarn floats to the technical back of the fabric. Loops can be made to float over a series of wales. To make the structure secure, some float yarns can be tied into the ground with a jersey or tuck stitch. Float loops make the fabric more narrow and less extensible because the floated yarn is in a straight configuration. Why would you produce a structure with loops that float? Floats are useful for pattern effects, where some colors appear on the front and others are hidden on the back. This checkerboard pattern uses gray and white yarns. When the gray yarn knits, forming a gray square on the front, the white yarn floats to the back. If you turn the fabric over and inspect the back, the colors appear reversed. A second use is to create surface effects or change the performance of the fabric. You can make loops float on one side of the fabric, then nap them to produce a fleece. If not napped, these floats can be used for aesthetics or function. You've just seen how 3 stitch formations can be used in different ways. All can be produced on warp or weft machines, or used for single or double knits. Whether circular knit or flatbed machines are used to produce double knits, there is some variance in how needles are employed to create this fabric. Both sets of needles can be used at the same time or at different times, but they don't touch or hit. How are they positioned and activated to accomplish this? On a knitting machine, needles are gated or spaced in the dial and the cylinder in relationship to each other. With rib gating, the 2 sets of needles are not directly opposite each other. The needles of the cylinder are between the needles of the dial. Here you can see how both sets of needles can knit at the same time without touching or hitting each other. Although all needles have the same length, the butts are in 2 different locations, which activates the needles to create patterning. Rib gating results in a fabric where face loops and back loops alternate in the same course. A face wale is made by needles on the cylinder. A back wale is made by needles on the dial. Look closely at the structure of the fabric, and you see that a vertical line or wale of visible crowns is arranged between 2 vertical lines of visible legs. This construction is 1x1 rib, where both sides of the fabric look the same. There are different notation systems for needle selection. This example shows how knit loops alternate 1x1 on dial and cylinder needles. This notation is for a 1x1 rib. Notice that both long butt and short butt needles are selected. This notation is for a 2x2 rib. Here you see that for each feed of yarn, 2 loops produced on the dial are alternated with 2 loops produced by the cylinder. Note that with this configuration, only needles of long butt positions knit, while the needles with short butt positions do not knit. Because basic rib knits have alternation of face and back wales, the structure can easily be stretched. In the normal relaxed state, the back wales hide behind the face wales. When stretched in the width, the structure opens like an accordion, resulting in more stretch than single knits and other double knits. The back wales now become visible. When pulled in the length direction, the back wales move behind the face wales and the fabric becomes more narrow. Because of this extensibility, basic ribs are used for sweaters and dresses, as well as for neck collars, arm and waistbands. We've just shown you two of the simplest rib-gated double knits. Another commonly used construction for rib-gated double knits is Swiss piqué. Its structure is a bit more complicated. This notation shows you the pattern for knitting on the cylinder below and the dial on top. With feed 1 of yarn, the machine knits on all the cylinder needles, but on the dial, the machine uses only the needles with long butt positions. With feed 2, it misses all the cylinder needles and knits only the dial needles with butts in the long position. With feed 3, the machine knits with all the needles on the cylinder, but only with the dial needles that have butts in the short position. With feed 4, the machine knits only on the dial needles with short butt positions. The Swiss piqué produced from this needle pattern has a distinctive texture and appearance. The fabric produced has good stability and does not curl. A second type of gating, where needles are placed opposite each other, is interlock gating. This results in different performance. In interlock gating, cylinder and dial needles are spaced so they're directly opposed. To prevent needles from hitting each other during the knitting cycle, opposing needles are not selected at the same time. When needle 1 in the cylinder is knitting, the corresponding needle 1 in the dial must rest. This is achieved by the alternating needles in the dial and the cylinder never being activated at the same time. This requires 2 cam tracks for both needle beds. Therefore, the location of the butts on the needle shank must be in 2 positions. Most commonly used are butts in short and long configurations, as seen in this illustration. Needles with long and short butts are alternately arranged in the cylinder and also in the dial. During each feed or course of yarn, only half the needles are used. On course 1, only needles with long butt positions knit, those placed in odd positions of the cylinder and even positions of the dial. On the second course of yarn or feed, the short butt position needles knit, in even positions of the cylinder and in odd positions of the dial. 2 feeds are required to complete a full visual course of interlock knit, whereas in 1x1 rib knitting, only 1 feed is required to make a visible course. Look at the resulting structure of an interlock fabric. Follow one course across different wales, and you will see a complex knit. Remember that 2 feeds are required for 1 course of knit. This first colored yarn knits on odd dial and even cylinder needles. The second colored yarn knits on odd cylinder and even dial needles. Because loops interlock and alternate from the front to the back, the structure of interlock fabric is much more rigid and stable than that of a rib. At closer inspection, you can see that interlock is the meshing or interlocking of 2 1x1 rib courses. This prevents adjacent wales from having mobility. Different double knit constructions can be made on rib and interlock gated machines. Needle selection by mechanical and/or electronic systems, along with yarn selection, determines the design effect. A variation of an interlock knit can be used to produce a structure that is tight and stable, where one course of fabric is attached and interlocked while the next is not. Ponte di Roma, used for women's dresses and suits, is an example of this. This fabric has the same appearance on both sides. Here's the notation for this type of fabric. During the first 2 feeds, the machine knits interlock. With the third feed, the machine knits jersey on only the cylinder needles. At feed 4, jersey is knit on only the dial needles. It takes 4 yarn feeds to make 2 visual courses. Although it is smooth, Ponte di Roma has a slight horizontal rib appearance and is thicker and more stable than interlock. After the knitting machine has been selected and the pattern capability is known, a designer turns their attention to the technical design. The designer gets started by deciding how large the canvas should be. The size of the pattern area is determined by the number of courses and wales that will conscribe and contain the pattern. Then comes the creative part of the design. Ideas for a motif can come from anywhere, like a natural object, like a feather, shell, or a leaf. Patterns abound in fine and applied arts. Paintings, sculpture, textiles, and other mediums can be a source of inspiration and motivate the styles of representation. In some cases, the designer may begin with a scanned image and then isolate and rearrange parts. Digital imagery enables designers to modify and generate original patterns. Using computer-aided design, the designer may change or reduce the number of colors. As images are repositioned or change size, the pixels, or small dots representing color on a computer screen, can become fuzzy or jagged. Careful attention to process is required to clean up the design. Once the design is crisp, the designer produces a variety of pattern repeats to create the composition of the final design. Patterns can be replicated side by side, half-dropped, staggered, or tiled. The motif can be sized, flipped, mirrored, or rotated. Parts of the picture can be filled with different colors to complement the overall design. Once the final pattern is selected, the designer instructs the computer application to convert it into a technical design. The computer determines what needs to happen at every feed with every needle. Colors seen on the screen, real colors, are converted to system colors, which are later translated to instructions understood by a knitting machine. On the CAD system used for this illustration, only 3 colors are used to identify which type of stitch is used to produce a pattern. White symbolizes a knit, green represents a tuck, and red defines a float stitch. In this technical design, feed 1 is at the bottom. Across this course, you can count the number of needles used for each pattern repeat. At this point, a designer must shift from aesthetics to technical concerns and take into account what format is used on the machine designated to knit the fabric. Is the knitting machine mechanical, or is it an electronic machine? The layout of the pattern is affected by what type machine is used. The designer indicates which knitting machine will be used, and based on its type, the designer inputs the number of feeds, the number of needles used, and what yarn is assigned to which feed. The designer compares the intended design with what can be produced based on the capabilities of the knitting machine. For instance, a 2-color pattern planned for a single knit must be expanded because there is the option to knit, tuck, or float at each feed. When the designer is confident that desired results can be achieved, the designer instructs the computer application to translate the design information into a language that can be interpreted by a particular knitting machine. If the machine is mechanical, driven by a drum, a pattern wheel, or step jacks, the instructions relevant to a particular machine are detailed on a printout. These printed reports specify technical information such as how to peg drums, how to slot wheels, or what step jack selection applies to a particular machine. If the knitting machine is electronic and equipped with a controller, instructions can be saved to a disk and loaded directly into the machine. In some manufacturing settings, instructions can be routed from the designer's computer to the knitting machine on the factory floor. Designing knits. In the next few selections, you see how patterned knits are created based on carefully thought-out technical design plans. A specialized form of knit, referred to as jacquard, can be produced when needles are manipulated independently, as yarn and color are introduced. Fabricated on machines set up for a single or a double set of needles, this form of knit affords designers the freedom to create complex patterns and intricate motifs. During the planning phase, artistic talents merge with technical knowledge of how machines actually knit. Before imagination takes hold, questions that influence the design and use are asked first. What is the target market for this product and application? Will the fabric be used for outerwear, intimate apparel, sports, or casual wear? Will the garment be worn by women, men, juniors, or children? What kind of motifs might be appropriate for the audience and end use? Once the desired outcome has been identified, plans can begin for how the fabric will be produced. The first thing to consider is construction. How does the fabric need to be structured to perform well and present the right look? Does it need to be stable or stretch? Should it have texture or be smooth? The second factor to consider is the content of the fabric and what combinations of yarn or fiber types might be used to alter performance or effect. For instance, you can produce exercise garments requiring a fabric that can have more stretch and better recovery by adding 5% spandex to a fabric that is initially 100% cotton. Different colored yarns or fibers can be combined to produce design and color effect. The third factor influencing design is how colors are used. Once the basic pattern is established, the colors of the basic fabric can be altered. You can begin with fabric knit using yarns dyed different colors to create a pattern design. Or you can take a fabric knit with all natural cotton yarns and piece dye to whatever effect you want. Or you can create a design by knitting with two colors, for instance, using natural and black yarns, and then over-dye to a particular pastel or medium color requested by the customer. With this method, variations in different shades and color schemes can be easily produced. We mentioned that the fiber content of the yarns can be chosen to affect color. Because different fibers react differently to dye, there are variations you can intentionally produce. Fabric made up of different type fibers can be cross-dyed, so that each fiber becomes a different color. One dye is selected to color the cotton fiber. Another dye is selected to color a second type of fiber. The advantage to this approach? One fabric created from two different yarns can be kept in inventory and later be dyed to many different color effects. Another approach, union dye, refers to a technique used to dye two fibers the same color using two different dyes. Here, two different fibers were dyed the same shade to achieve the appearance of a solid-colored fabric, which takes advantage of the physical and aesthetic characteristics of each fiber. In addition to dyeing applications, yarns can be combined for special effects. You can introduce texture and interest by incorporating novelty yarns, such as boucle, textured yarns with nubs or slubs. The content of the yarn, the size of the yarn, and the appearance of the yarn all play a part in how the structure will look. The size of the yarns in the mix you've selected makes a big difference in what machines can be used to produce the fabric. Once all the decisions have been made about fabric construction, the content of fibers, and the colors, attention turns to the knitting machines available for use. Which machines have the capabilities needed to fulfill performance requirements? The final design motif is transferred from the studio, on paper or disc, to the factory floor, where fabric construction begins. If the knitting machine is electronically controlled, the instructions needed to interpret a pattern are loaded into the machine. If the knitting machine is mechanical, technicians examine the printout to note specifics on setting drums, wheels, or selection devices. Regardless of the machine, yarns must be placed in the proper sequence on the creel. Here you see how yarn positioned to knit a two-color jacquard pattern is set up, so one color knits on even feeds of yarn, the other on odd feeds. To ensure that the machine properly knits, all technical information must be correct. Also set is the length of the stitch. Stitch adjustments can be made to change the width, weight, and hand of the fabric. Stitch length affects how the pattern will be seen. Smaller stitches create a tighter, smaller pattern than stitches of longer length. Once instructions have been loaded or followed and all functions are set, it's time for a trial run. First, the machine is jogged so it moves slowly. Then, the first course of knit is carefully examined to see if needles are doing what is expected. If everything is operating properly, the decision is made to increase to full knitting speed. When a representative sample has been successfully produced, the machine gate is opened and a portion of fabric is snipped off. Technical diagrams, graphs, and printouts of the pattern are compared to the knit fabric to make sure the pattern is accurately represented and knit correctly. Problems can occur if yarn is out of place, if needles have not been properly selected, or there are pattern mistakes. If the pattern meets with design expectations, the decision is made to move forward. Before going to full production, technicians complete a spec sheet, detailing information about the type of machine, the correct settings, the type of yarns used, as well as the weight and width of the fabric. Also noted are course length, stitch length, and machine speed. To visualize how the finished product appears in garment form, it's back to the studio to evaluate results. A designer might select a picture from a magazine or a stock photo appropriate to the application of the fabric. The designer can either import the design into the application or scan the fabric itself. Next, the design planned earlier is scaled and texture mapped so it fits the garment worn by the model, and the final effect is reviewed. You've seen how construction can vary and design can be enhanced easily using knitted fabric. Because it is so convenient to manipulate needles and the resulting structure, knits can quickly be brought to market. For their wide range of performance, drapeability, strength, and ease in wear, the consumer chooses